morning, students. Okay. Good morning. So, shall we start with the revision? Fine. So, this is related to revision of this particular topic. Okay, na? So, as I told, in your test from this topic, we will be having from classification of organic compounds. Then you will be having with respect to IUPAC nomenclature. Then you will be having with respect to isomerism. Then with respect to heterolytic and homolytic cleavage. Okay, so these are some of the concepts which will be there for your test. Okay, na? So these are some of the concepts which will be there for your test. Anyway, I think they will put it in the group also. You can inquire in the group also once again if any confusion is there. Fine, but these are some of the concepts which you can expect for your exam. Now, first we will go with the classification. So in classification we have aliphatic molecules. Okay, aliphatic molecules. Now, can anyone of you tell me what you mean by aliphatic molecules, or what are the features of aliphatic molecules? Can anyone of you tell me? What are the features of aliphatic molecules? Anyone? So what do you mean by aliphatic molecules? What are the features of aliphatic molecules? Fast. Fast. Aliphatic molecules. So these are the non-cyclic compounds, right? So when I am telling non-cyclic, naturally they should be non-aromatic. When I am telling non-cyclic, they should be non-aromatic compounds. Because for aromatic compounds, one of the basic requirement is they should be having a cyclic structure, right? So they should be having a cyclic structure. That's why we have the aliphatic molecules, which are open chain structure or non-cyclic structure, and which are non-aromatic in nature. Okay, so Ashish, that's what. For aromatic compound, they should be having the ring structure. But here, since it is non-cyclic, naturally they are non-aromatic in nature. We can give plenty of examples for this. It can be butane, ethane, ethyl alcohol, or propyl alcohol, all of them. They can be the example for aliphatic organic compounds. Okay, now next one, that is related to cyclic organic compounds. That is with respect to cyclic organic compounds. Now all of us, we know that it can be classified into sorry, it can be classified into aromatic and non-aromatic compounds. It can be classified into aromatic and non-aromatic compounds. Okay, so basically, okay, before that, basically we can make them as homocyclic and heterocyclic. Homocyclic and heterocyclic. Okay, before that one we can do this one. Homocyclic and heterocyclic. So what do you mean by homocyclic? Where only carbons will be there in the ring. Only carbons in the ring structure. But here in heterocyclic we can have other elements including carbon. Other elements along with the carbon. Okay, along with the carbon. So that's where we have the homocyclic and heterocyclic. Say for example, I have cyclohexane. I have the cyclohexane, which can be the example for homocyclic compound. Then I have the benzene, even which can be an example for homocyclic compound, benzene. Right? So now if I take this one, that's where I have the non-aromatic, that's where I have the aromatic. So non-aromatic and aromatic compounds. Non-aromatic and aromatic compounds. Okay? So directly when I am talking about heterocyclic, here also we can have aromatic and non-aromatic compounds. Aromatic and non-aromatic compounds. Okay? So when I am talking about non-aromatic compound, I can take the help of tetrahydrofuran. Tetrahydrofuran can be the example. Okay, so with respect to non-aromatic compounds. So what about aromatic compound? Can anyone? I can take the help of either furan. This is tetrahydrofuran. So I can take the help of furan where double bonds will be there. Where there will be presence of double bond. Okay. So or even we can take the help of pyrrole ring. Aromatic, heterocyclic aromatic compounds. Okay. So that's where we have the cyclic compounds. Classification with respect to cyclic compounds. Okay. So what is the compulsion for aromatic compounds? Aromatic compound should follow Haeckel's rule. Anyway, that will be there in your hydrocarbon topic. So this will be covered in your hydrocarbon topic. No need to worry. Okay, na? So therefore, aromatic compound should follow Haeckel's rule. Then it should have the cyclic structure. So that's where we have some of the features or requirement for a molecule to behave as a aromatic compound. All of you have understood? Any doubts with regard to this one? Okay. So shall we move to the next one? That is with respect to IUPAC nomenclature. So I will give some of the examples. We will start solving that one. Okay. So example can be, okay, here I will write CH, double bond, CH, double bond, CH2. Okay. So this is a given organic compound. They have given in the exam. We will imagine that its examination is going on and they have given the molecule. ಹಾಗಾದ್ರೆ when I am talking about this molecule, when I am talking about this molecule, the question will be write the bond line structure. Write the bond line structure. That is one question. Then write the hybridization. Write the hybridization of the carbon. Okay, so this is the question. And another question can be write whether it is saturated or unsaturated compound. This will be the question. Now when I am talking about hybridization, simply I have written as write the hybridization. Now they can ask the question as write the number of carbon with sp hybridization, or write the number of carbon with sp2 hybridization, or write the number of carbon with sp3 hybridization. They can specify. Okay, they can specify. So for practice purpose, I have given it as hybridization. All of you got my point? Now, first we should write the bond line structure. So first we should write the bond line structure. Now 1, 2, 3, 4, 5, 6. It is a 6 carbon containing molecule. So 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6. So that's what 1, 2, 3, 4, 5, 6. We have to show it in zigzag form only. Bond line structure always should go with the zigzag representation only. Then between first and second carbon we should number like this. But anyway, here in this between these two carbon we have a triple bond. Then next between these two carbon there is a double bond. There is a presence of double bond over here. And finally between these two, once again there is a double bond. So this will be the bond line structure. So I got 1 mark for this. Now we will imagine they have asked about sp hybridized carbon. We'll imagine number of carbon with respect to sp hybridization. How to find the sp hybridization? It's very simple. So if I take these two carbon, now hydrogen is there, triple bond is there, then carbon is there. How many sigma bond with respect to this carbon? 1, 2. No lone pair of electrons left over. Observe here carefully. No lone pair of electron which is left over. Only 2 sigma bonds. So therefore it should be having sp hybridization. What about this carbon? Only 2 sigma bonds. These two are pi bonds. Pi bond should not be considered when I am talking about hybridization. I should consider lone pair of electron if it is there. Ashish, you should not think, you should be sure. Yes, it is an unsaturated compound. Okay. Now when I am talking about this carbon, 2 sigma bonds are there. So please remember, pi bond or pi electrons should not be considered with respect to hybridization. We should consider those which are involved in pi bond and with respect to lone pair of electron if it is left over. Naturally, carbon does not have any lone pair of electron in this condition. So it is having only 2 sigma bonds. So therefore, even it should be sp hybridized. What about this? This carbon is having 1 sigma bond, 2, 3. So it's not a sp hybridized carbon. So So what about here? 1, 2, 3. Between hydrogen also bond is there, right? So 1, 2, 3. So it is also not a sp hybridization. So here also it is not a sp hybridization. So only 2 carbons are there with sp hybridization. So I will write it as 2. So I will write it as 2. Another 1 mark. I will get another 1 marks. Now, they might have asked about sp3 or sp2. They might have asked about sp2, number of carbon with respect to sp2 hybridization. Okay, so in that case, I can see sp2 present over here because this carbon, imagine I will be writing here, hydrogen is there and double bond, right? This one only. So sigma bond, sigma bond, sigma bond. No pi electron. So therefore, 3 hybridized orbital, that is SN1, S1, P2. Okay, that's why sp2. So this is sp2. So here also 3 sigma bonds. So therefore sp2. What about here? Here also 3 sigma bond, sp2. What about here? Observe this one. So here we have the carbon with 2 hydrogen. So naturally sigma, sigma and sigma. This is 5. So therefore here also it is sp2. Here also it is sp2. So what I mean to tell you is total we have 1, 2, 3, 4. So 4 sp2 hybridized carbon. I will get 1 marks. Total 4 sp2 hybridized carbon. Yes, Ashish. It will be 4 carbons. Okay, na? Hagadre, if they ask about sp3, any sp3 hybridized carbons are there? No. So I can directly write it as 0. So 1 marks. Any one of this hybridization they will ask. Either sp3, yes, it should be 0. So either they will ask sp3 or sp2 or sp. Then you should mention what is that number. No need to give the naming and all. No need to numbering and all. Total number of carbon just you should mention. That's all. Okay. So that's why we have got the another 1 mark for this. Next one. Whether it is a saturated or unsaturated organic compound. That will be the question. That will be the question. It will be like a main question will be there. In that it will be like a sub question. Each question will have the 1 marks. Each question will be having 1 mark. Okay, another one. IUPAC nomenclature. So another 1 mark. So total 4 marks, or they can go even up to 5 marks. Okay, so that's where naturally, since there is a presence of double and even triple bond is there, even 1 double bond or 1 triple bond, we can consider that compound as unsaturated. It will be unsaturated. Okay, another 1 marks. Another 1 marks. Okay, it is a unsaturated organic compound. So, what is the IUPAC name? What is the IUPAC name? Anyone? Preference wise, which will be given preference? Double bond or triple bond? So, it will be for the double bond. So, therefore, please remember numbering will be done from here 1, 2, 3, 4, 5, 6. Okay, so it is a hexane derivative. It is a hexane derivative. Fine, it is a hexane derivative. Yes, Rakesh. Preference should be given to double bond, not to the triple bond. But the name of the molecule should end up with triple bond. Name of the molecule should be ended up with triple bond. This one you should remember. Okay, sir. Therefore, name of the molecule should be ended up with YNE. WINE ಅಂತ ಬರ್ಬಿಟ್ಟಿರಾ? Okay, this YNE. Name of the molecule should end up with YNE. Right? So, how to name the molecule then? So 1, 3 double bond, at 5 triple bond. So I can mention this one as Benz. Mercedes Benz, something you should be thinking. Oh, sorry, why Benz? Okay, it is a hexane. It is a hexane, right? So hex 1, 3 diene, comma 5 YNE, comma 5 YNE. Okay, so that's where we have the name of the molecule. Hex tells that it is a 6 carbon molecule, 1, 3. We are talking about even first carbon also because 2 double bonds are there. So therefore 1, 3 diene, 5 YNE. So name of the molecule should have ended up with YNE. All of you got my point? So if I write like this, another 1 marks will be given to me. Another 1 marks will be given to me. This type of question they have asked many times. All of you got my point? So that's where we have the IUPAC name, bond line structure, then hybridization, then whether it is saturated or unsaturated. All of you got my point? So it can be asked 3 or 4 or 5 marks. If it is for 3, only 3 sub questions will be there. If it is 4, then all this type of questions will be there. If it is 5, another hybridization they can ask. Okay? So that's where we have the IUPAC naming of the molecule and finding the hybridization of a given carbon in a given organic compound. Okay? Same way, when I am talking about, once again I will tell many students they will get confused when I am talking about the hybridization. So they will be confused. So how to write the hybridization? That's where they will get confused. Once again I will tell. I have a carbon. Okay. Now it is having 4 sigma bonds. Sigma bonds means there should be single bond, which you people have studied in your chemical bonding topic, right? So if that is the case, 4 sigma bonds are there, then I should consider this one as a sp3 hybridization because total number of bond is 4. So total number of hybridized orbitals should be 4. That is 1s and 3p orbital. Total it will be 4. So no need to mention 1 here because it's understood. Otherwise S1, P3, no problem. But it's understood. Okay. Now I have a carbon. It is having a double bond. Then here we have the condition with respect to the carbon. Now if I see whenever double bond is there, in that only one will be sigma and another one will be pi bonding. Right? What is sigma bond? Head to head collision. Head to head overlapping of the orbital. So what do you mean by pi bond? Sidewise overlapping. Okay? So sidewise overlapping or pi bonding we should not consider for hybridization. So this is also sigma bond, this is also sigma bond. So how many sigma bonds are there? 3. So therefore 3 hybridized orbitals are required. One is S and another one is sp2 or s1p2. That is nothing but 1 plus 2. 1 plus 2. Total hybridized orbital is 3. Okay. Same way, I have a carbon where it is having a triple bond. Now, all of us we know that when I am talking about triple bond, there will be presence of 2 sigma bonds. Means in a triple bond, 1 sigma bond and 2 pi bonding. So therefore, yes, since there is 2 sigma bonds, I should consider 2 hybridized orbital, that is S1, P1. So therefore, 1 plus 1. Therefore, 1 plus 1. Like that we should calculate. Okay, like that we should calculate. Now, can any one of you tell me what is the amount of p sub shell, or what is the sp hybridization? What is the share between s and p orbitals? What is the share between s and p orbitals? Can any one of you, percentage wise, you should tell me what is the share between s and p orbital? Hmm? Anyone? So it's very simple. If that is the case, it's very simple. So total number of orbital is 2, right? So total number of orbital is 2. So in that 2, what is the s? It is 1. So for 100, because we are talking about the percentage. So 50% of s character. Naturally, same thing will be applicable for p also. 50% of s character. So same way we can calculate for sp2 also. Same way we can calculate it for sp2 also. So what is the total number of hybrid orbitals? It is 3. How many s orbitals are there? It is 1. For 3 it is 1. How much for 100? So what is that answer you are going to get? What is that answer you are going to get? Hmm? What is the answer? 100 divided by 3. 100 divided by 3. How much? Yes, it will be somewhere around 33%. Somewhere around 33%. I am talking about S character. I am talking about S character. Here also I have discussed about the S character. So what about this one? What is the amount of S character? So total number of orbital is, hybridized orbital is 4. So in that only one S character. What about for 100? How much? It will be somewhere around 25%. It will be somewhere around 25%. That's where we have the S character. That's where we have the S character. Okay, so this is how we can calculate the amount of S character. Okay, so this is how we can calculate the amount of S character. Now we can tell that as the S character increases, as the S character increases, electronegativity of that carbon, electronegativity of carbon will increase. ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. As the S character increases, electronegativity of carbon will also increase. That means in case of the sp hybridization, electronegativity of carbon will be high. Then comes the sp2 hybridized carbon, and the last one is sp3 hybridized carbon. And the last one is sp3 hybridized carbon. Any doubt with regard to this one? So this is how we can calculate the S character. Even P character also we can do. Only thing is we have to reverse this. With respect to sp it will be same, but here it will be different. So you can easily calculate 100 minus 33, that will be P character. 100 minus 25, that will be P character in sp3. Okay, all of you got my point? So whatever I have written, it is related to S character. If I want to go with the P character, so directly you can calculate 100 minus 50, that is 50% only, P character. So 100 minus 33, so that will be P character, somewhere around 67, right? So 100 minus 25, that is 75 will be P character. Okay? But when I am talking about S character, as the S character increases, electronegativity of that carbon is going to increase. Okay, So therefore, sp, S character is increasing, therefore sp hybridized carbon will be having stronger bond. Triple bond will be of stronger bond. One is, since there is a presence of 3 bonds, and if I consider with respect to the carbon, since there is an increase in the S character, therefore the bond strength will also increase. All of you have understood? Okay? So I will take another example. So 1, 2, so this is the molecule. This is the given molecule. Now naturally the question is, write the bond line formula or bond line structure. That is first one. Okay. Second one is IUPAC name. IUPAC name. Then with respect to sp, sp2 and sp3 hybridized carbon number. Any one will be asked. For practice purpose, I am giving all the 3. Okay. And the fourth one will be whether unsaturated or saturated organic compound. Unsaturated or saturated organic compound. You should mention unsaturated or saturated. Okay, so all of you can give me the answer. This one I will write. Okay, this one I will write. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. At third carbon there is a nitrile group. So 1, 2, 3. So there is a nitrile group. I can show it like this. There is a nitrile group. Okay, there is a nitrile group. So this is the bond line structure. This is the bond line structure. Be careful. So we cannot show bond line structure for this one like this. Okay, so this will be wrong. We should take one line so that indicates that there is a carbon, that triple bond end. That does not exist. That one does not exist. Okay, fine. Now IUPAC name. Now you should tell me the IUPAC name. Now you should tell me the IUPAC name. Now you should tell me the IUPAC name. Bond line structure, I got 1 marks. What about IUPAC name? Anyone has written? You have to practice. No other option for you. What will be the IUPAC name? Three-amine hexene. No. How come it will be 3-amine? CN is not a amine group. Amine group means Rohan. Amine group means NH2. But here it is C triple bond N. So one is, this is amine and this will be nitrile. Nitrile. And please remember, nitrile will be having the preference. It should be used as a suffix. It will be used as a suffix. Yes, nitrile group. Okay. Now, can you tell me IUPAC name? I will give a hint. I will give a hint with respect to this one. See, I have a compound. Okay. So what is the name of this molecule? 3-nitrile hexane. Oh, that's what. I told preference should be given to nitrile group. So therefore, the numbering should be done from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have to give preference to this carbon because it is a functional group. So 1, 2, 3, 4, 5. Purposefully I wrote this one. Counting 1, 2, 3, 4, 5, 6. That's what I have written. I know my students will make the mistake. Okay, you should not do the mistake. So therefore I was telling from that time that this nitrile group should be given the preference. Same as here, see, this carbon also considered as a parental chain carbon. Therefore we will call them as ethanoic acid, right? Same logic is applicable here. So in that case, we can name the molecule as anyone? We can name the molecule as, we can name it as 2-ethyl. So we can name it as 2-ethyl. Now 1-pentonitrile. 2-ethyl pentonitrile. Got my point? So selecting the parental chain, please remember when you are selecting the parental chain, you should consider this carbon, preference should be given to this. I know this is having longest carbon, but still, since functional group is here, we should consider this carbon preference. So from here, what will be the longest chain? So 2-ethyl pentonitrile. Okay, pentonitrile. All of you got the point? Okay, all of you got the point. You have to practice. So 2-ethyl, 1 it's not required, Shashank. We can simply mention as 2-ethyl pentonitrile. It's understood. It's understood. Nitrile, name of the molecule should end up with nitrile. So pentonitrile. Okay. So that's where we have the IUPAC name. Now you should tell me what is the number of sp hybridized carbon. What is the number of sp hybridized carbon? So I got 1 marks over here. What is the number of sp hybridized carbon? What is the number of sp hybridized carbon? So please remember, first preference should be given to carboxyl group. Then comes the sulfonic acid group. Then comes the nitrile group. Please remember. Then amino group, hydroxyl group, and all it will come. Okay. So that's where the preference list will go on. Okay. So Ashish is writing sp hybridized carbon is 1. All of you will agree with him. What is that sp6? Shashank is writing 6. Oh, okay. So sp hybridized carbon according to Ashish it is 1. According to Shashank it is 6. All of you will agree with whom? Either Shashank or Ashish. Shashank removed. Good. That is wrong answer actually. Okay. So now whatever Ashish has given the answer, that is correct. This is the carbon which is sp hybridized carbon. No other carbons they are sp hybridized. Okay, so that's where we have the sp hybridized carbon. So with respect to sp hybridized carbon, it will be 1. What about sp2? What about sp2? Anyone is there? Any of the sp2 hybridized carbon over here? Can you tell me? Yes, Ashish, very good answer. So there is no sp2 hybridized carbon. It is zero. It is zero. Very good answer. It is zero. Yes, all of you correct now. sp2 hybridized carbon is zero. Okay, nothing. No carbon is with double bond. Anything with respect to sp3 hybridized carbon? Anything with respect to sp3 hybridized carbon? Hmm? How many are there with sp3 hybridized carbon? Yes, all of you correct. It will be 6. It will be 6. These are the one. So sp3, sp3, even this will be sp3, this will be sp3, this will be sp3, and this will be sp3. So total 6 sp3 hybridized carbon. Okay. Now next question is important. Whether it is saturated or unsaturated. Hmm? Yes, Ashish, I was expecting unsaturated. No, it's not unsaturated. Since this is a functional group, so we'll consider only this carbon. Between the carbon, there is no double bond. Between the carbon, there is no double bond, only sigma bonds. So it's not unsaturated, it is a saturated compound. Because among the carbon, there is no double bond. Please remember, between the carbon, there is no double bond. All are single bond. So therefore, it will be saturated. That's what I told in the earlier case also. Means during the class, I told that carboxylic acids, carbonyl group, they are having double bond, but still this molecule will be considered as a saturated one. Why? Because between the carbon there is no double or triple bond. You have to remember this one. So try to practice more question like this. You can expect the question from here, or even percent S character and all. You can expect the question from that particular part also. What is the percentage of S character? What is the percentage of P character? S character they will ask normally. Then with respect to hybridization, we can expect the question. So try to practice. Okay. So you can finish it up. If you are 100% thorough, then within 2 minutes you will get the 5 marks. Bumper drop, right? Within the 2 minutes you are going to get the 5 marks, because just mention one word, that's all. Whether it is unsaturated or saturated, just you should mention saturated. 1 marks will be given to you. No need to explain. What are saturated compounds? No need to explain. Okay, just saturated. If they ask what are unsaturated organic compound, then you should tell. A organic compound containing double or triple bond between the carbon in its structure will be considered as unsaturated organic compound. But here, no need to explain, just write the answer. Okay? Whether I am clear? Okay? So, another important concept will be related to isomerism. Another important concept will be with respect to isomerism. But please, once again, I am telling you have to practice more question on IPAC nomenclature. So go to your check sheet, go to your textbook, solve as many as possible with respect to IPAC nomenclature. So see the preference list. So based on that, you should give the answers. Okay, na? Now, another important concept will be isomerism. Now, anyway, I'll be talking about structural isomerism. I'll be focusing on structural isomerism or structural isomers. So, isomerism is a process. Isomers means a group of organic compounds. Okay. Now when it comes to structural, first one we have discussed is chain isomers. Chain isomers. So what do you mean by chain isomers? Where they will be having same molecular formula but different way of parental chain will be arranged. That means we should not get same parental carbon. For example, if I am talking about 4 carbon or 5 carbon, so nowhere it should be repeated as butane. I will take the example. CH3, CH2, CH2, CH3. Right? So if I want to write the IUPAC name, this one will be given as N-butane. This one will be written as N-butane. Now, I will take CH3, CH3, CH3. So what is the IUPAC name? I am not talking about common name. IUPAC name. It will be 2-methyl. 2-methyl propane. Now see the difference. Here it became propane, but here it is butane. So that's why it is called as chain isomers, because their parental carbon will be different, but molecular formula will be same. So therefore, they are called as chain isomers. They are called as chain isomers. Fine? All of you got my point? Same logic is applicable. For example, CH3, CH2, 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 CH3. IUPAC name is N-pentane. Okay? Now, but if I take another molecule, CH3, 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 CH3. This can be named as neopentane, no doubt. It can be named as neopentane. But if I go with the exactly IUPAC name, I should write it as 2,2 dimethyl. 2,2 dimethyl propane. Can you see? Here it is pentane, here it is propane. So therefore, they are the examples for chain isomers. They are the examples for chain isomers. Okay, in the examination they can ask, what are chain isomers? Explain with example. Then you should give one example at least. Okay, you can take butane or you can propane. We cannot have, please remember, from butane we can have the chain isomers. Propane, no. We have N-propane, cyclopropane, but still they are having propane as the name. Okay, now that's where we have the chain isomers. Next one will be position isomers. Next one will be position isomers. It can be with related to functional groups or it can be related to unsaturation. That is double bond or triple bond. So that's why we have the position isomers. All of you got my point? That's where we have the position isomers. See, for example, I have CH3, CH2, CH2, CO, CH3. So this is the molecule. So what is the name of the molecule? Name of the molecule is pentan 2O. So 1, 2, 3, 4, 5. Pentan 2O. Same way, I can write the molecule CO, CH2, CH3. Now what is this? This is nothing but pentan 3O. An example for position isomers. An example for position isomers. Okay, even hydroxyl group at different positions, right? So that's where we have the position isomers. Next one is functional group isomers. Next one is functional group isomers. Okay, na? So next one is functional group isomers. Okay. Now when I am talking about functional group isomers, it can be acetone or propanone and propanol. Acetone or propanol means what? Aldehyde. So what I mean to tell you is acetone means propanone. This is the one. Acetone or propanone. What a one and all same. So another one will be CH3, CH2, CHO. So propanone, propanol. They can be the examples. Okay, or same way we have CH3, CH2OH, ethanol and dimethyl ether. Dimethyl ether. Ether and the alcohol. Isomers. Ether and the alcohol, they can be the examples. All of you got my point? And the last one is metamerism or metamers. So what do you mean by metamers? Where we will be having different substituents surrounding the functional group. Ethers can be the best example for this. For example, C2H5O, C2H5. So that is ethoxyethane. Then another one can be CH2, CH2, CH3. So that is methoxypropane. Ethoxyethane, methoxypropane. So like that we can have the structural isomers with respect to metamers. So please practice even this one. And when it comes to homolytic and heterolytic cleavage, so try to understand carbocations, hybridization of the carbocation. Okay? So now, same way we have carbon radicals which will be formed during the homolytic cleavage. Under which condition these radicals will be formed with respect to their stability. So all these things you should understand. Okay? Fine? So anyway, I will stop here. You have to do well in your exams. Any doubts with regard to this one? So once again, practice whatever IUPAC nomenclature is there in your check sheet and in your textbooks. Practice that one. Okay? Thank you then. Thank you. All the best. Do well in your exams. Wow. Board is blurred. Okay, sorry, Appa. Now I saw that one. Vishwas, now I saw whatever you had written. Okay, anyway, I finished the class. So try to practice with IUPAC nomenclature. Okay? So thank you. Thank you very much. Question in the sense about the intermediates. Which type of intermediates will be formed when a molecule will go for heterolytic or homolytic cleavage? Like that question can be asked. That is carbocations, then carbanions or carbon radicals. So primary, secondary, tertiary. So try to understand that one. Okay? Okay then. So thank you. Thank you very much. Bye. Take care.